classes, right? In the previous classes you already learned different type of the numbers, whether it may be natural numbers, whole numbers, integers, rational numbers, irrational numbers, even numbers, odd numbers, prime numbers. Like this we already studied the different type of the numbers. Just first we will recall that all the different type of the numbers. Means the first one is natural numbers. So natural numbers means these are obviously counting numbers, right? If I say to count the any objects or particular things or student, means you will always start from one only, right? For example, if I start counting the letters which are existing in the world, irrational means this is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 letters are existing in the word irrational. Like this we are counting. So natural numbers means these are the counting numbers. Natural numbers are the counting numbers which start from 1 and it is denoted by the symbol. It is denoted by the symbol n. So first one is natural numbers. Natural numbers, and it is denoted by the symbol n, and these natural numbers are start from 1, 2, 3, 4 and so on, right? Now next one, the whole numbers. Whole numbers means what? The numbers which start from 0. The numbers which start from 0, we call it as a whole numbers. Whole numbers. And these whole numbers are represented with a symbol W. So whole numbers are start from 0, 1, 2, 3, 4 and so on. Next, move to the next type of the number, that is integers. Integers. So integers are the numbers which existing, which includes both positive, negative values, both positive values and negative values along with a 0, for example, and these integers are indicated by the symbol I or Z. So here we are using two different letters to denoting the integers. So what are the letters? I or Z. I or Z. Okay. So integers means the numbers which includes both positive and negative along with the zeros. Means -4, -3, -2, -1, 0, 1, 2, 3, 4 and so on. So these are the some number of integers belonging to the set of integers. Okay, next one, rational numbers. Rational numbers. These rational numbers are the forms of the real numbers. Again, we are dividing the real numbers as two types. First one is rational number, and second one is irrational number. Irrational number. So what do you mean by the rational numbers? Rational numbers means the numbers which can be represented in the form of P by Q. Whatever the numbers which can be represented in the form of P by Q or A by B or X by Y. In that the denominator is not equal to 0. It means here Q is not equal to 0. P is in the numerator place and Q is in the denominator place. B is not equal to 0. Here Y is not equal to 0. Right? So these type of the numbers are called as the rational numbers. For example, all the fractions, what we are writing, all the fractions, no, these all belongings to the rational number. 2 by 3, 3 by 4, 5 by 7, 8 by 9. So these all are the group of the rational numbers. Examples for the rational numbers. So in that the denominators are not equal to 0, right? Next one, irrational numbers. So how you can define the rational numbers? The numbers which can be expressed in the form of p by q. The numbers which can be expressed in the form of p by q. In that q is not equal to 0. Okay, we will discuss in this session only. We will discuss briefly in this session about the rational numbers and irrational numbers. This is our main concept, rational numbers and irrational numbers. Okay, I'll discuss next one. Irrational numbers. Irrational numbers means it's the opposite. Here we are representing the numbers in the form of p by q, but in irrational numbers we cannot represent the numbers in the form of p by q. We cannot represent in the form of p by q or in the form of a by b or in the form of x by y. We cannot represent the numbers in the form of p by q. These kind of the numbers are called as the irrational numbers. For example, root 3, root 5, root 7. So these are the examples for irrational numbers. Now, root 4 is a rational number or irrational number. How you are getting whether the given numbers are rational numbers or irrational number? Just observe this one. What is the value of root 3? We cannot get any approximated value here, right? We cannot get the accurate value. For example, here root 3 value is 1.8, 1.82 or 83. Sometimes we also consider it as a 1.8 also, right? So these numbers will not have a definite value. When we are representing in the decimal expression, decimal expansions, the digits will be sometimes repeats and the digits will be terminates, right? But the 4 has what is the square root of 4? 2. So 2 is rational number or irrational number? Means 2 is a rational number because the denominator of any number is always 1. The denominator of any number is always 1. So it is in the form of p by q. Here it means the irrational number means non-perfect square numbers. For example, 1 is a perfect square number. Square root of 1 is 1. 2 is non-perfect square. 3 is non-perfect square. 4 is perfect square number. Square root of 4 is 2. Right? Next one. 5 is non-perfect square. 6, 7, 8. And 9 is also one of the perfect square numbers. So, for example, root 1, root 4, root 9, root 16, root 25, root 36, root 49. So, these kind of the numbers are not considered in the irrational numbers because when we are calculating the values of these numbers, that numbers can be easily represented in the form of rational numbers. So it means all the non-perfect square numbers, are irrational numbers. And one more thing, pi is the symbol pi. You already learnt in the previous classes. What is the value of the pi? 22 by 7, right? Pi is irrational number, whereas 22 by 7 is a rational number. Why? Because we are writing in the form of p by q here. 22 by 7 is in the form of p by q. That's why 22 by 7 is a rational number, but pi is a irrational number. So this is the one of the important concept. In most of the exams, they ask whether pi is an irrational number or rational numbers. Yes, pi is a irrational number. Pi is a irrational number, but 22 by 7, what we have the value of pi now? 22 by 7 or 3.142, right? So that is the rational number. Okay, next one, 0. 0 is rational number or irrational number? 0 is a rational number. 0 is a rational number. We can write like this: 0 by 1. 0 by 1, it is a rational number. We can represent the number in the form of p by q. So 0 is a rational number. So these two are the important concept, important points right? So pi is a rational number, pi is a irrational number, but the pi value 22/7 is a rational number, and 0 is also rational number. Next one, what we discussed in what we learnt in the previous classes, even numbers, odd numbers, co-prime numbers, right? So even numbers means, just I will recall that, even numbers means the numbers which is divisible by 2. The numbers which is divisible by 2, exactly divisible by 2 without leaving any reminders are called as a even numbers. So I already know the even numbers. Examples for the even numbers is, this is just basics only, 2, 4, 6, right, 8, 10. So these are the even numbers. Next one, odd numbers. What are the odd numbers? 1, 3, 5, 7, 9. These are the odd numbers. Now one more concept is there, that is prime numbers. So prime numbers means what? Prime numbers. Prime numbers means the numbers which have only 2 factors. The numbers which have only 2 factors, that type of the numbers are called as a prime numbers, or the numbers which is divisible by 1 and itself. The numbers which is divisible by 1 and itself is called as a prime number. For example, here 1 is divisible by 1 only, 2 is divisible by 1 and 2, 3 is divisible by 1 and 3, 4 is divisible by 1, 2, 4, 5 is divisible by 1 and 5, 6 it is divisible by 1, 2, 3 and 6, 7 is divisible by 1 and 7, 8 is divisible by 1, 2, 4 and 8, 9 is divisible by 1, 3 and 9, right? Take up to 10, 10 is divisible by 1, 2, 5 and 10. You already know natural prime numbers, right? So here 1 is divisible by 1 only, but 2 is divisible by 1 and 2, 3 is divisible by 1 and 3, 4 is divisible by 1, 2 and 4. Here the prime numbers means the numbers which is divisible by 1 and itself. Itself means it is divisible by the same number. So that type of the numbers are called as a prime numbers. Here 2 is the first prime number. 2 is the first prime number. Next one, 3, 5, 7, right? So these are the some examples for prime numbers. Prime numbers means what? The numbers which is divisible by 1 and itself only, or the number which has only 2 factors, right? So these type of the numbers are called as a prime numbers. Then what to give the name for other these numbers, 4, 6, 8, 9 and 10. So these are the composite numbers. These are the composite numbers. So composite numbers means, how we can define the composite numbers? The numbers which is divisible by, the numbers which is divisible by more than 2 factors. More than 2 factors, are the number which have more than 2 factors are called as a composite numbers. Here the first composite number is 4. The first prime number is 2. The first composite number is 4. The first prime number is 2. The first composite number is 4. Then what about 1? 1 is neither a prime number nor a composite number. Okay, 1 is neither a prime number nor a composite number. And one more thing, only one number, 2 is the only one even prime number. If you are writing prime numbers, in that 2 is the only one number which is even as well as a prime number. Okay, other than 2 we cannot get any even prime numbers, right? So 4 is the smallest composite number, 2 is the smallest prime number, 4 is the smallest composite number. So all the composite numbers are having more than 2 factors. Okay, and next one, prime numbers and composite numbers. If you are writing the prime numbers from 1 to 100 means in between 1 to 100 we have totally 25 prime numbers, totally 25 prime numbers. Okay. Composite numbers means the numbers which have more than 2 factors. Next one, co-primes, co-prime numbers. So co-prime means what? Any two numbers which have the common factor 1 only. For example, if I am taking 2 and 3. So what are the factors of 2 and 3? 1 and 2, 1 and 3. Here 1 is a common factor of these two numbers. Or co-prime means the HCF of any two numbers is equal to 1 means then that two numbers are called as a co-prime numbers. 5 and 7. What are the factors of 5? 1 and 5, 1 and 7. Factors means you already know that in the previous classes you already learned. Factors means the number which divides the given number without leaving any reminders. So 1 divides 5 without leaving any reminder. Again that 5 is divisible by 5 without leaving any reminder. 1 5s are 5 and 5 1s are 5. So here we have the common factor 1. So these type of the numbers are called as a co-prime numbers. All the co-prime numbers have the common factor that is 1 only. Okay, but now in this chapter we are discussing about these two concepts only, rational numbers and irrational numbers. The concept of irrational numbers is basically originated from the Greek word. Some famous mathematicians like Pythagoras and Archimedes. Archimedes is a famous scientist also. He introduced the concept of irrational numbers, and later the mathematician Archimedes find the value of pi. He introduced the concept of pi. One more Indian mathematician Ramanujam find the value of pi. As we know that pi is nothing but 22 by 7 and its value is 3.142. He calculated the decimal points up to millions, right? So this is the history about the rational numbers and irrational numbers. Now the main concept is rational numbers. Now you are getting some idea about the numbers. Natural numbers belongs to whole numbers. Natural numbers belongs to whole numbers. Whole numbers belongs to integers. And this integers belongs to rational numbers. And rational numbers belongs to real numbers. Right? So, but symbolically we are representing as the first one is a number. This number is classified as a first one imaginary numbers. Imaginary numbers and real numbers. Imaginary numbers and real numbers. And these real numbers are again classified as rational numbers and irrational numbers. Irrational numbers. Next one, these rational numbers again we are dividing it as integers. Integers, and these integers we are dividing as whole numbers. If it includes 0 means it is a whole number. If it starts from 1 means it is a natural number. Right? So this is the symbolical representation of the number system. Here imaginary number means what? Imaginary number means if any number existing in the negative values of the square values, negative square roots are the best examples for imaginary numbers. Imaginary numbers means we cannot say the exact value of that given numbers. Okay, now come to the main concept, that is rational numbers. You already know that the definition of rational numbers. Rational numbers, and these rational numbers are representing with the symbol q. So how you can define the rational numbers? The numbers which can be represented in the form of p by q is called as a rational numbers. The numbers which can be represented in the form of p by q is called as a rational numbers. Rational numbers. Here q is not equal to 0. Q is not equal to 0. Okay. If q is not equal to 0 means, if q is equal to 0 means what we will get? We get infinity, right? So all the rational numbers are in the form of p by q. Then what about the value of p and q? Whether the p is, it may be positive or negative or 0 also, right? P only, I am telling only about the p. P it may be positive or negative or 0 also. It means it can directly say, we can directly say it as a p is a integers. P is a collection of the integers. It has positive values, negative values and 0 also. So every decimal numbers are also in the form of the rational numbers. Okay, and if I write p by q is a form of the rational number means its negative term is minus p by q. So these are the some basic properties of the rational numbers. Next one, equivalent rational numbers. Equivalent rational numbers, you already studied in the fractions. Equivalent rational numbers. So equivalent rational numbers means what? How we are writing the equivalent fractions though? Like that we can write the equivalent rational numbers by multiplying or by multiplying the same digit, same number to a given rational numbers, we get some equivalent rational numbers. For example, 2 by 3. 2 by 3 is a form of the rational number because it is in the form of p by q. So 2 by 3 is a example for rational number. If I multiply 2 for both numerator and denominator, what I will get here? 2 2s are 4 and 3 2s are 6. Again multiply 2 for both numerator and denominator. Next number is 8 by 12. 4 2s are 8, 6 2s are 12. Again multiply 2 for both numerator and denominator. 16 by 24. So these type of the numbers are called as the equivalent rational numbers. Equivalent rational numbers. Okay. If I divide these two by using 8, 8 2s are 8 3s are. What we are getting here? 2 by 3. What we are taking initially? 2 by 3 only, no? So these type of the numbers is called as a irrational equivalent numbers. Rational equivalent numbers, right? Next one, simplest form of the rational number. Simplest form of the rational number. So simplest form means what? Simplest form means further we can not reduce the any given fraction, and what we are converting the given fraction into simplest form, no, their common factors is always one only. For example, here if I am taking here 24 by 36 means these two are existing in the multiples of 6. 6 fours are, right, 6 fours are 24, 6 6 are. You can also divide 24 and 36 by 12 are. Divide it by 4 also, right. 2 2s are, 2 3s are. So 2 by 3 is the simplest form of the given rational number 24 by 36. 24 by 36 is the given rational number and its simplest form is 2 by 3. So what are the factors of 2 and 3 here? The factors of 2 is 1 and 2 and the factors of 3 is 1 and 3. So 1 is a common factor in these two numbers. It means when we are converting the rational number, when we are converting the rational number to its simplest form, no, their HCF is 1 only. It means here the 2 and 3 are the two co-prime numbers. So it's one of the important property of the rational number. The rational number is in the form of P by Q, no? The P and Q are the two co-prime numbers. P and Q are the two co-prime numbers. So all the co-prime numbers are having only one common factor, that is 1 only, right? So this is the one more property of the rational numbers. Next one, if you are adding, some more properties are there. If you are adding the rational number, if you are adding two rational numbers, we get again rational numbers only. For example, 2 by 3, it's a example for rational numbers. If I add one more rational number, 3 by 5, just add these two numbers, what I will get? What is the LCM? Here denominators are different, 3 and 5 are the two different digits. So before adding these two, we have to take the LCM of these two numbers. So 3 and 5 LCM is 15. If 15 is a LCM means what I have to multiply here? 5 and here 3. No, 2 5s are 10, 3 3s are 9. So what I am getting now? 19 divided by 15. 19 divided by 15 is nothing but it is also one of the rational number, because it is in the form of rational number only, P by Q form only. So first one is when we are adding two rational numbers, the resultant value is also rational only. Second one, when we are subtracting two rational numbers, we are getting rational number only. For example, 3 by 2 minus 1 by 5. Again the denominators are same, so just take the LCM of these two. The LCM is 5. Now if LCM is 5 means what you have to multiply? Here 5 and here 2. 2 5s are 10 and 5 2s are 10. 3 5s are 15 minus 1 2s are 2. So 15 minus 2 is 13 by 10. So when we are subtracting two rational numbers, the resultant value is always rational number only. Next, third one, 3 by 5 and 3 by 4. 3 by 5 and 3 by 4 are the two rational numbers. Just multiply these two rational numbers. 3 3s are 9. 4 5s are 20. So the resultant value is also one of the rational number. Okay, next one, 5 by 4 divided by 2 by 3. So just divide this one. In the division of the fractions, we take the reciprocal of the second fraction, right? This is already learnt in the previous classes. The first fraction we write as it is 5 by 4, whereas the second fraction we are taking the reciprocal of that, and the division becomes multiplication. So 3 by 2, 2 by 3, the reciprocal of 2 by 3 is 3 by 2. 5 3s are 15, 4 2s are 8. What we are getting again? The rational number only. It means the sum of any two rational numbers, or the sum of the subtraction of any two rational numbers, or the multiplication of any two rational numbers, or the division of any two rational numbers, the resultant value is always equal to be rational number only, or it's always in the form of rational number only. Okay. So these are the some basic properties of the rational numbers. Now we move to the next concept, that is the rational. Write the rational numbers. Write the rational numbers between any two rational numbers. We are writing the rational numbers between any two rational numbers. First one, write rational number between 3 and 5. Write the rational numbers between 3 and 5. This is the first type question. In that you have to take the two values as a x and y. 3 and 5 are the two given values. You need to take that two values as x and y, and the condition is x is always less than y. So x is equal to 3 and y is equal to 5. So it should be satisfied the given condition, that is x is less than y. X value is always smaller than the y value. So that's why I am taking here y as a 5 and x as a 3. Okay. Next one. So how we are going to find the rational numbers between any two numbers? If these two are the values, means we are calculating the required rational numbers by using the formula half into x plus y. Half into x plus y. 1 by 2 into, what is that x value? 3. Y value 5. 1 by 2 into 3 plus 5 is 8. So 8 ones are 8 divided by 2. 2 ones are 2 twos are. Sorry, 2 fours are. 4 by 1. 4 by 1 is the one of the rational number between the two given numbers 3 and 4, or you can also take it as a 4. 4 is the rational number. The denominator of all natural numbers and whole numbers is always 1 only, right? So this is the first type question. Next one, second one. If you need to find the rational numbers more than 1, means one more formula is there, that is write the rational numbers, or find 4 rational numbers. 4 rational numbers between 3 and 7. 3 and 7. So how you are going to find the two rational numbers? 4 rational numbers between 3 and 7. So the given formula is, here also we take it as the x and y are the two values. X is always smaller than y, so x is take it as a 3 and y is take it as a 7. The condition given is x is less than y. X is less than y. So first you need to find the d value. D value, the formula is y minus x divided by n plus 1. Here y means what? 7, x means 3 and n means how many numbers you are going to be calculating. So you are calculating 4 values. So n is equal to 4. N is equal to 4. So once we calculate the d value means the one more formula we are getting, that is x plus d, x plus 2d, x plus 3d, x plus 4d. So these are the 4 required values. So first calculate the d value. What we are getting the d value? D is equal to y value is 7, x value 3 divided by n means 4 plus 1. So 7 minus 3 is 4 and 4 plus 1 is 5. This is the d value. By using this d value, we need to write the 4 rational numbers which is existing between 3 and 7. So we have already one standard form, that is x plus d, x plus 2d, x plus 3d, x plus 4d. Just substitute the x value and d value in this form. So x value is 3 plus y, d value is 4 by 5. Second one, x value is 3, 2 times of 4 by 5, 2 times of 4 by 5. Next, third one, x value is 3 times of 4 by 5. Next, last one, x means 3 plus 4 into 4 by 5. So just simplify, we will get the rational numbers. Here what's the LCM? 5, because the denominator is always 1, right? So 5 means what you have to multiply? 5, here 1. So 5 3s are 15, 15 plus 4 is 15 plus 5 3s are 15, 15 plus 4 is 19. This is the first rational number. Next one. First convert this one in the form of improper fraction. This is the mixed fraction, no? Convert it to improper fraction. 5 2s are 3 plus 5 2s are 10, 10 plus 4 is 14 by 5. Without converting also we can calculate. Okay, so now again the LCM is 5 means LCM is 5. So what I have to multiply here? 5 3s are 15, right? 5 3s are 15, 15 plus 14 is 29. Next one, write this 3 as it is. 5 3s are 15, 15 plus 4 is 19, 19 divided by 5. Take the LCM of these two. Denominator is always 1 means 5 is the LCM. If 5 is the LCM means I need to multiply 5 here. 5 3s are 15, 15 plus 19. 15 plus 19 is nothing but 15 plus 19 means 34 by 5. And next one, similarly calculate this one. 3 plus 4 5s are 20, 20 plus 4 is 24 divided by 5. Denominator is always 1. Okay, so denominator is always 1 means LCM of these two is 5. I need to multiply here 5. 5 3s are 15, 15 plus 24. 15 plus 24 is 15 plus 24 is 39 by 5. So the required rational numbers are 19 by 5, 29 by 5, 34 by 5, 39 by 5. So this is the way to represent or to finding the rational numbers between any two given numbers. Okay, this is the first method. I think this will be lengthy. Now I will show one more method. It will make so simple. And one more thing, keep in your mind, you can write infinite number of rational numbers between any two numbers, whether it may be positive numbers or negative numbers also. So these are the two examples to write the rational numbers between the two given numbers. I think these two are lengthier methods. Now I will show you how you can find the rational numbers in the simple form. Either you can solve by using this method or one more method. The simplest method is there. By using that method also you can find the rational numbers which are existing between the two rational numbers. Already told you, you can write infinite number of rational numbers between any two given numbers. For example, now here I am taking three examples and show you how you can write the infinite number of rational numbers. Okay, first one, write 6 rational numbers. 6 rational numbers between 4 and 9. What are the given numbers? 4 and 9. Here I am not taking any value as a x or y. Just take these two values, 4 and 5. So 4 and 9 are the two given values. We already know that the denominator is always 1. The denominator of any value is always 1. So these two are the values. No, for these values you need to multiply the same number. Either you can multiply 100 or 1000 or 10 or 10,000, but you should be multiply the same number for these two fractions, and should we multiply the same number for both numerator as well as the denominator. Here I am multiplying 10 for the first fraction, and the same number I am multiplying for the second fraction. After multiplying 10 for these two fractions, what I am getting now? 4 tens are 40 divided by 10. 9 tens are 90 divided by 10. Now these are the two rational numbers. Now write the rational numbers existing between 40 by 10 and 90 by 10. 40 by 10, 41 by 10, 42 by 10, 43 by 10, 44 by 10, 45 by 10, 46 by 10. Like this, we can write infinite number of rational numbers. What they ask here, write the 6 rational numbers. You can write infinite number of rational numbers between any two given numbers, right? Here I am multiplying 10 only. Just think that if I multiply 100 for these two number means I can write easily more than 1000 numbers also, no? So this is the one method to finding the rational numbers between any two rational given numbers. Okay, now but in this method you need to keep the main point in your mind is you need to multiply the same number for both the fractions. What we are taking that fractions, no, we need to multiply the same number for both numerator and denominator. Okay, next, second method. Now I am taking two different numbers. Write the rational numbers between 2 by 3 and 5 by 3. 2 by 3 and 5 by 3. Just observe the given fractions. What are the given rational numbers here? 2 by 3 and 5 by 3. In the place of denominator, the values are same, 3 and 3. In these types, we just multiply, same method. We are applying the same method in this fraction also, in this rational number also. The first one is 2 by 3 and second one is 5 by 3. Now I am multiplying 10 for these two fractions, for both numerator and denominator. Now 10 2s are 20, 3 10s are 30, 5 10s are 50, 3 10s are 30. Again we have two same denominators. So you can write the rational numbers from 20 by 30 to 21 by 30, 22 by 30, 23 by 30, 24 by 30, 25 by 30, 26 by 30. This is the easiest method, no? Now see the next method. 3 by 5 and 6 by 7. In first method I am taking directly two numbers. In second method I am taking two rational numbers. These two also rational numbers. The denominators of these two also 1 and 1, right? In second method I am taking two rational numbers, in that the denominators are same. In third method I am taking two rational numbers, their denominators are different. In this case we need to find the LCM of the denominators. LCM of the denominators. So 3 by 5 and 6 by 7 are the two given rational numbers. So what is the LCM of 5 and 7? LCM of 5 and 7 is 35. 5 sevens are 35. So write 35 in the place of denominator. 35 is a LCM, means what I have to multiply here? 5 sevens are 35. Here 7 5s are 35. Now multiply the numerator. 7 3s are 21. 6 5s are 30. Now you can write easily the rational numbers which is existing between 21 by 35 and 30 by 35. So 21 by 35, 22 by 35, 23 by 35, 24 by 35, 25 by 35, 26 by 35, right? Here I am not multiplying anything. Suppose if I am multiplying any 10 or 100 or 1000 means I can write infinite numbers, no? So we can write infinite number of rational numbers between any two given numbers. Okay, so these are the some basic concepts related to the rational numbers. In the next class we will discuss decimal expansion, how we are going to be represent the rational numbers in the form of the decimal expansions, right? In decimal expansions we have some repeated non-terminating and terminating concepts also, right? So until then, be happy, have a nice day. Thank you for watching.